thank you. And in being invited to talk about this topic, it's such a huge topic and it's such an important topic, isn't it? This for this day and age and for the impact that technology is having on society. So it's fairly high level and just trying to provide a mix of inputs. But I'm just curious to start with, especially seeing we have a small group. Are there any questions at all that people have that might reflect, that particularly that you'd hope to discuss? And I can't guarantee I'll get to them, but if you let me know, I can see how we go. I'll get ready to take a note. Anything in particular that people are curious about? And I can't see the chat. Where is my chat window? Okay, got my chat. So you can do it in chat or so feel free to interrupt anyway as we go along. I'm hoping not to speak for too long and we can have discussions at the end. And I just have another question for you to think about here, which is, would you say you're biased? So just putting in the chat, can you say Y or N for yes or no? Would you say you're biased? So there's a question there about the main dimensions of difference. I think we'll get to some of that. Just make a note. So just curious whether you think you're biased or not. Yeah, we're all biased in some way, probably. And I think that the main message that I would like to talk about today is that diversity matters, and it matters not only for the technologies that we develop, but for us as researchers, and all of our general practices as researchers, developers, peer community, and that we really need to take it seriously because good science depends on it, and good technologies that come out of our science depend on it. Now, what's good obviously can be judged differently by different people. So I'm not talking about perfect or universally agreed, but something that's good enough. And also that diversity matters, which is really matters of diversity, include way more dimensions than we may have ever first considered, as Miriam said in the introduction. And what we need to do and be as practitioners, researchers, developers is really be reflective about what dimensions of diversity might matter for this particular situation that we're in right now, because it's going to be different. And also recognizing that notions of diversity are not enough, especially when we're talking about our own practices, that we also need to really take matters of equity and inclusion seriously. And I'll try to unpack those a little bit, albeit very briefly. So why diversity matters? Well, we know that, of course, we know, especially coming from computer science areas, that there are all sorts of gender and issues in computer science. There are lots of initiatives about trying to increase the proportion of women and diverse genders. There's loads of literature that indicates there's gender bias in evaluations and hirings, and just more generally. So this isn't just in academia, but generally, that people will write different sorts of reference letters, even given the same criteria, they'll judge people differently depending on whether there's a woman's name or a man's name attached to the head of that list of CV. And there's also other ways that gender bias plays out just in work practices. Women are often interrupted and spoken over more often in meetings. We know in academia, women tend to do more academic citizenship that isn't really so visible in valuation criteria for promotions and so on. And we know that in particular, the COVID experience has significantly impacted the issue of gender and the disparities that are there. So, within our own context, professional context, there's a whole lot of bias and issues there just around gender. And we also see in the literature that a lot of this biases, for example, also play out in hiring, not just for women, but for people with disabilities, people who look different to us, older people, people of diverse genders, and so on. So just in our everyday lives, there's a whole lot of issues played out with diversity, not playing out practically in the way that we want. And we see these sorts of biases reflected in our technology. So if you do a search in Google Images for personal assistant, what do you see here? They're mostly women who come up as personal assistants. We also see that reflected in a lot of the personas that our chatbots and that and our sort of personal assistants have, and technical personal assistants have, which are often female personas. And if we do a search on professor, we get predominantly men, white men, old white men. So, again, these biases that are playing out in society reflected in our, the data that's fed into our technologies through which we can ask these sorts of queries. And I'm sure you can all come up with loads of examples of different ways that these sorts of biases play out in practice. So there's some quite seminal work that Joe Bullambini talks about in this TED talk here about how faces like hers with darker skin tones and diverse facial structures aren't recognized in face recognition algorithms. So literally making people invisible or just not recognizing them as people, reflecting the bias and the lack of diversity in the training sets that were training these face recognition algorithms. So this was work that she did as a grad student at MIT. And the algorithm hadn't been taught to identify a broad range of skin tones or facial structures, so it just didn't. It was very good at what it was taught to do. We see biases playing out in the justice system, and we know that this plays out ordinarily in the justice system, and we know that the figures about the incarceration of people of color is significantly higher and they get harsher sentences. And we see this reflected again in risk assessment, automated risk assessment software that is supposed to be helping judges make sentencing decisions. And if you just look here at this here with, James Ravelli and Robert Cannon, just as two counterexamples, if you look at the list of prior offences that James Ravelli has on his profile relative to the petty theft prior offence of Robert Cannon and subsequent offences, none for Robert, 1 grand theft for James. Yet when it comes to sentencing decisions as input to the judge's decision, James Ravelli is marked as a low risk for reoffending and Robert Cannon a medium risk. And there's a whole lot of data reported in this paper that highlights the biases reflected in the algorithms, in the data that's informing the design of these algorithms, that reflects societal bias coming through. So biases around gender and race are often very commonly ones that are reported when we hear about biases. And there are also other ways in which we might play out biases here in things that we might not even think about that are less critical than, say, judicial sentencing. So the work of Christine Christina Bauer and Andreas Ferraro, found that music recommendation algorithms are unfair to female artists. Why? And would you have ever considered that? Because you would think that it's about the music and not the gender of the artist. And there's a report from the ACM Europe group and their technology policy committee that really unpacks a lot of the ways that gender bias plays out in the targeting of job advertisements, and just general, in particular as one way, and generally sort of the way in which the bias is introduced to this software can actually have significant impacts on the career progressions of women. So there's some really, and there's loads of literature that supports these sorts of ways in which our bias data sets, the bias training data sets introduces the biases into the systems, and those systems introduce biases into our everyday processes, whether it's the music we listen to, the sentencing that a judge gives, or whether you are called forth to have a job interview or not because of automated algorithms. But this is another dimension of diversity that we might not have ever thought about. So this is a graphic representing one of the very early YouTube video uploading apps for iOS. And the development team were really wondering, scratching their heads about why were 5 to 10% of the videos that were being uploaded to YouTube upside down. And the simple answer is that, like they were sort of wondering whether people were shooting videos incorrectly. But the simple answer is no, that their early design was wrong. It was designed for right-handed users. And when they're held in left hands, though, if you're a left-handed person, you normally rotate the phone about 180 degrees. And so without realizing it, and unintentionally, because they hadn't considered this as a dimension of diversity that might matter for this particular application, they had designed and created an app that worked exclusively well for right-handed people, like all the developers in their team, and didn't take account of the 10 to 15% of the population who are left-handed. And I want to just, again, like there are many more examples, but I just want to give one example of a clinical area. So hospitals, medical work, clinical work. And the trigger for this is a special issue that just got released last week in the Transaction on Human-Computer Interaction. And a lot of the papers here are somehow addressing issues around clinical practice and the way that artificial intelligence or machine learning becomes implicated into this. And so this reflects a lot of the research that we've done over the years in healthcare practice. And I used to be a nurse and a midwife before I did computer science, so it's an area that I'm particularly passionate about. And one of the things I've always been passionate about from the very early days in the late 90s when we started working in the clinical area or health informatics area was the ways in which our imaginations of what technology could do, and it could be done at a technical level, did not fit into the ways that doctors and nurses and pharmacists and physios and so on worked in the hospital. And it was quite horrifying the number of times of the repeated themes and patterns across studies about the ways in which these technologies actually got in the road of caring for a patient. And that's what clinical staff are on about, caring for patients, not caring for technologies. And I think healthcare is a really, really complex space. So I'm just going to pick one of these papers here. So this is the last paper you just see. There are many more papers in this special issue. This is just to give an example. But this last paper, I'm going to just take this as an example. So they talk about, they have this model, they did this review across a whole lot of studies of AI and machine learning type models being actually deployed into clinical practice. And this qualitative meta review that draws out some of the, that draws out some of the ways in which data gets used to support and through their analysis, decision support, prioritization of, should this patient be brought into emergency straight away, or can they sit in the waiting room, or should they be put up the waiting list for operation and so on, or automation of tasks. So they were their broad three categories that they identified in their meta review of the literature. And they also created this nice model, and I'll show you the model later about the way in which AI and machine learning gets used for clinical practice. And they start off, they have multiple steps that I'll show soon, but they start off with the training data. And one of the issues that they identify is the importance of the accessibility and quality of the training data, because the whole system depends upon the quality of this data in the first instance, in the way that we've just seen with all the other examples. Now, the data that I'm going to show you now is not from their paper or their studies, but it's going to tell a little bit of an illustrative story from studies that we did a few years ago in the UK, looking at general practices using electronic health records in their practices when they were had patients coming to see them. And we were particularly interested in how they use the free text to write down descriptions. So the example here on my right, I think it's your right as well, would be an example of someone using a lot of free text to write a history, and to the extent to which the doctors would use the features built into the electronic health records they use to do more structured coding from structured coding lists. And this is an example of a note taken by one of the doctors that we studied that used more structured coding. Now, one of the issues with the training data that is used for the decision support for the machine learning for clinical practices, for those three purposes that we talked about before, depends upon structured data being put in. So for a start, there's a whole lot of interesting information that's written up in the free text that won't ever get reflected in the structured data if the doctor hasn't also chosen some specific structured code to reflect what they put there. And our studies, watching the doctors interact with some actor patients that we'd set up for them to consult for a consultation, and using different systems, our studies showed that doctors really struggled with using these coding systems. They got in the road. The coding systems were great for the administrators, for the government to allocate funding back according to codes. They're great for epidemiologists to do population level research about, do patients with headaches get better if we give them a Panadol, if that's been coded. But for doctors sitting with a patient, Mary, in front of them who they want to treat, and knowing they've got a waiting room full of people, they just wanted to get to the nub of the problem that this person had and make a good enough decision. And we saw again and again and again multiple ways in which they either chose not to code, or they just chose wrong codes because of problems with the system design, and it made the drop down list or whatever, or the predictive text made it too easy. For example, one of the examples is they might be writing that a patient had stopped smoking, and the predictive text would recognize smoking and then bring them up a code list that says about smoking, not smoking, because it didn't recognize the given up smoking. And so there are lots of ways in which the designers of the system often triggered them to pick wrong codes, because they would just either dismiss it or just pick something to get it out of the road. And here are just a couple of quotes about the problems that the the patients had, and this is from work that a master student, Christian Lerv, did in going through some of this data, so it takes them a while to get used to the system. I know what to write. I remember the beginning when I started, it was a bit difficult to put in some of the things, but I know what I'm looking for now. So there's that whole learning curve, and your structured data set free text mix doesn't reflect that. It just assumes everything's equal. The problems they had picking the code. So there might be a code for particular things that could be useful for the epidemiologists or the policymakers or the, now for our machine learning models. But it didn't come to mind for them. So rather than put in the time going through all of the coded structured coding lists, they just put it in the free text, because the point for them about documentation in an electronic record is to keep a record of their decisions and to help also inform colleagues who may also see this patient. And whether for them, from a clinical point of view and interacting with the patient, whether the note about what they saw in the examination is in the free text or the structured code, it sort of doesn't matter as long as it serves the purpose of communication. But the machine learning model doesn't know that the training data set is missing this information, which may be really important because it's sitting in free text, and that's not included in the training set. So, and again, just going back there, because I don't know what I did there. So there's a whole lot of other examples where they put in the wrong code, they didn't bother correcting it, they just put in anything to keep the computer happy so that they could move on. And yet this is the foundational data set for the training model. So that's problem number one. But then in their paper that just got published, where they report on this qualitative review, they also identify the ways in which this is just the beginning of a whole, what they call the socio-technical context of use. So it's not like they're having the good data on which the model is trained is sort of like a necessary but not sufficient condition, because then there's a whole lot of other issues that come into play about how does this system, even if we assume that the model is good and correct, how does this system get used and integrated into everyday practice? And that's from the interoperability of systems and communication, infrastructural workflows, from the user interface aspects to make it easy for people to interact with and to make sense of, say, the recommendation for prioritization, to how people understand what's going on, to the whole workflow, how these fit into their workflow, their sense of responsibility to patients, and also the legislative, financial, all sorts of other institutional, organizational policy aspects around it. So it's really complex, really complex. And they talk about the ways in which it's not just the problems with the lack of good quality data in the training model because of the variability in the structured data, the nuance and noise and so on, but also how it gets integrated into workflows. And in particular, this paper points to or unpacks from their qualitative review the diversity of stakeholders. So they need HCI practitioners, machine learning practitioners, a whole range of health practitioners, and just saying doctors and nurses doesn't catch it, because it's much more complex. There's allied health like physios and occupational therapists and so on. There's the administration, there are the technology support people in the hospital, there are all the people in the government and policy arena, and so on and so on and so on. And just trying to get all these people to work together to work out how to deal with these socio-technical challenges is problematic because of their epistemological and methodological differences in working together, and because they have different concerns and values. And I did a podcast interview. I have a podcast series called Changing Academic Life. And I did a podcast interview with Moshi Vadi, who's very vocal, writes a lot for the communications of the ACM magazine. He had an interesting reflection to make. So to quote him, he talks about, we realized recently that computing's not a game, it's real. It brings with it societal benefits, but also significant costs. like labor polarization, disinformation, smartphone addiction, YouTube uploaders that don't account for left-handed people, like machine learning algorithms for clinical records that don't have good data to make good recommendations that may impact whether someone lives or dies or gets an operation in a timely way. Suddenly, we computer scientists are running society and we're poorly equipped because we're trained on the technical issues. We're not trained so well to take account of understanding the broader socio-technical implications of our technologies. And I don't know what I'm doing with my keyboard here, but we can all tell loads of stories about the ways in which these sorts of technologies and getting it wrong and the impacts are playing out on so many aspects of society, of life. And so there's something about a real call at the moment for us to take the notion of being responsible computer scientists really seriously, because we're no longer, as if we ever were, just creating technologies. We're creating our futures. We're creating society. And a big part of being responsible, I think, is taking diversity and inclusion seriously. So just to unpack that a little bit, if you were to think about your current teams or your current systems, if we're going to move to different dimensions of diversity, or even people in this room, what are the different ways that you may consider that we're different? What might be our dimensions of difference? So we could, of course, talk about gender. But it could be cultural issues, it could be methodological preferences, it could be technical platform preferences. I know there could be lots of different ways, language, culture, I said. And this is just a brainstorm that I've sort of come up with, and I'm sure that you might have many more. And to the extent to which some of these might factor for either the technologies we're building or for the teams that we're working together with, or the people we're collaborating with to build these technologies, because they do interplay, don't they? As we saw with the YouTube upload, handedness. Miriam in the chat says communication styles and learning styles as well. Totally. So there's communication style here and learning styles. So there are lots of different ways that we could be different beyond the gender and cultural dimensions of diversity that often get talked about when we talk about diversity. And so it's worth thinking about, for your own area of work, for your data-centric work, the applications that you're working on, or for the research teams, what might be some of the dimensions of difference that matter for you? And maybe that you hadn't thought about. And I asked at the beginning, are you biased? Are you always inclusive and equitable? And the answer is, as someone said in the chat, we're all biased in some way. Ricardo says, I'm probably biased toward my view of the world. Indeed, I feel biased because of my age. I feel like I won't get the same opportunities as others. Indeed, like there's multiple ways in which we can be biased. And if the research makes it really clear that if we have a brain, we're biased, because we're biologically wired to be biased because it's a survival mechanism. So we may say we value diversity, but we'll still be biased. And it's a survival mechanism because bias is a way of seeing patterns, so seeing the pattern in the way I view the world. So you don't see reality. And these play out often in unconscious and implicit biases that we may not even be aware of, because we are just who we are. Does a fish talk about swimming in water? No, it just is. there's loads of research that talks about different types of biases, and I'm not going to go through them here. But this is just one model that I just think synthesizes some of the biases quite simply. So the experience here, my perceptions are accurate, because that's my view of the world. That's the glasses through which I see the world. And the similarity bias, I feel more comfortable with people like me, reflects often our choice of team members. We want more, we feel better with people who are like us. And I think it's useful to think about notions of diversity and reframing it not just as diversity, but reframing it as difference. And if we reframe it as difference, diversity is about difference, and because it's difference, it can make it harder for people to connect and empathize with each other, because we do have that potential for the similarity bias. And the thing about difference is we can often try to avoid it because difference can be problematic. But again, if we go back and think about our research teams that are part of making decisions for these systems, there's loads of research that says well-managed diverse groups outperform homogeneous ones where a lot of people are similar to each other, where they feel more comfortable. And these more diverse groups with much more different people are more committed, have higher collective intelligence, better at making decisions and solving problems. Exactly what we want when we're dealing with some of the really hard technical design problems we're dealing with today in this data-centric world, AI world. And again, many more studies, again, just some exemplars here just to reinforce that about the increased productivity, engagement, collaboration, financial performance, innovation, better problem solvers. So again, multiple research studies reinforcing that same message. And it's not just playing out generally. A lot of those studies are in more sort of a commercial context or industry context, business context. And even in science, we understand that scientific excellence depends on creativity, that creativity emerges from diversity, and the advantages of diversity are realized through inclusion, which I'm going to talk about in a tick. So there's clear evidence as well within our science that we're doing. Diversity is a good thing. And I think this is a really cute example. So this is a quantum computing article, and they talk about their techniques for solving a particular quantum computing problem to team building techniques. That if you form a team of experts with identical backgrounds, all of them may have the same blind spot, he said, adding a human dimension. If you want to make a team resilient to blind spots, collect a group of people who have different blind spots, who have different ways of viewing the world. And as a whole, the team will be guarded against specific blind spots. And so that reflects their choosing qubits with different error rates as part of their solving this quantum computing problem. So diversity, thinking about diversity, can help in all sorts of ways. But because diversity is about dealing with difference, it's also clear that working with difference can feel like harder work, because it is, because we're not feeling similar and at home more comfortable. It takes more work. We're more likely to have conflicts. We're more likely to have different points of view, different ways of doing stuff. I know that for the medical health application areas, if you want computer scientists to work together, especially human-computer interaction people working together with medical people, there's a fundamental difference, for example, in how we do evaluation. Medical people want randomized controlled trials. The HCI people will be saying, we're not ready for that yet. We need to know if the system's right. We want more qualitative, iterative, in situ evaluations. And these can be, sometimes it can take you a while to even realize that these are some of the tensions that you have. But again, the research says that even though diverse teams feel less comfortable because they are different and they have to deal with the consequences of their differences that are often not so visible at the beginning. That's why they actually perform better. And that's why we're going to get better systems in the end as well. The other thing then is, how do we, if we accept that we're all biased, and if we accept that we need to actually embrace diversity, how do we become much more reflexive? How do we think about diversity beyond just, so it's not like ignoring, we still have to think about our training data sets to ensure that they reflect as much diversity as is relevant for the situation at hand, or that we've taken into account the factors like handedness if it's relevant. But then how do we also, as researchers, practitioners, develop the self-awareness to ask the questions about diversity matters? What can we practically do to mitigate or minimize some of the biases? What new behaviours do we need to put in place to actually engage with diversity, deal with difference? That might mean new project development processes. How do we deal with collaborations in diverse teams so that we have, often my experience is we often have diverse teams on paper, especially for, say, some of the funding schemes that require you to have multidisciplinary teams. So you all look good on paper, but once you get the funding, everyone goes into their little disciplinary silo and just throws things over the wall to one another, and then we wonder why they don't work. And how do we have bigger cultural change towards equity and inclusion? And this is what I just want to say, that equity and inclusion is much more than diversity. So there's a way of thinking about this, that diversity is about the difference. So making sure that we have multiple people of different dimensions of diversity, whatever those dimensions are that matter for the technology at hand or the team at hand, sitting around the table, tick. And that's often where we stop, the tick box. We have our 20% of, whatever dimension of gender or culture or whatever. But do people have a voice at the table? That's inclusion. And if they do have a voice at the table, is that voice heard, respected, and valued? And that's equity, because we can give people a voice, but we may not respect it or take it on board. Again, it's sort of like another little tick box. And equity is really about working out how to equally bring in all of the different voices and perspectives and dimensions of diversity, and the challenge of engaging with those differences, because differences can create conflicts, and resolving them. That takes grown up cultures and reflective researchers and practitioners. So I've covered a lot here. You may want to think about what your key insights are for your technologies, for your groups. And just to reiterate that I think matters of D&I, we do need to take them seriously as responsible computer scientists if we're going to have good technologies that aren't just good technologies within their own little bubble, but that actually work in practice and transform society and processes in ways that promote the greater good as best as we can for the complex decisions that we're making now. And so we need to consider diversity for the technologies we develop. What dimensions matter? What do we need to include in our training sets? And for us as researchers and developers and peer communities, if we're working in developing technologies for these complex situated contexts like healthcare, how do we make sure we get all the stakeholders involved, contributing, having a voice at the table, and having a valued voice? Because I want to argue that good science and innovation in our digital futures, our society depends on that. And that means that we need to think about diversity matters beyond just the traditional gender and culture stuff. And that requires us to be much more reflective on diversity matters. And that diversity alone isn't enough, that we also have to engage with the consequences of taking diversity as difference and what that means to work with. So that's where I shall end it here and look forward to discussion.